Ever feel like the internet needs like a serious upgrade, especially when it comes to speed and cost?
Hmm.
Today, we're diving deep into the world of Ethereum scaling solutions.
Okay.
Specifically, something called the OP stack to see if it lives up to the hype. We're going deep with excerpts from Optimism's own documentation, and let me tell you, this stuff is next level.
Yeah,
It's exciting stuff.
it's really impressive how Optimism is tackling the limitations of Ethereum head on. Instead of hitting a wall, they're building a whole new highway system, so to speak.
Okay, I love that analogy.
Yeah.
So if Ethereum is our current highway, reliable but prone to congestion, what Optimism is proposing with the OP stack is like building a network of high-speed express lanes on top of it. These express lanes are called Layer 2 solutions in Optimism's grand vision. They're aiming to connect these lanes into something called a superchain.
And that's where things get really interesting. We're not just talking about making things faster. It's about changing how we even think about blockchains working together. Imagine a future where different blockchains communicate as seamlessly as sending an email.
Okay.
That's the promise of the superchain.
That's a huge idea. But before we get ahead of ourselves, let's break down how we even get there. Tell me, what exactly is the OP stack, and how does it make this whole superchain vision a reality?
So the OP stack is essentially the technology blueprint for creating these specialized layer 2 blockchains. Think of it like a highly sophisticated Lego set
Uh-huh.
designed to build custom blockchains that seamlessly integrate with Ethereum.
A Lego set for building blockchains. Okay, you've definitely got my attention.
Ah.
But like any good Lego set, there are instructions, right? Break down the different parts of this OP stack for me.
You're exactly right. The OP stack is broken down into 5 core layers, each with a specific function. The data availability layer, the sequencer layer, the execution layer, the roll-up layer, and the proof and fault layer.
5 layers, each with a unique role. Let's start with the foundation, the data availability layer. What's happening at this level?
So think of the data availability layer as a secure and transparent library for all transaction data. One of the most interesting things about the OP stack is that it can either tap into Ethereum's existing data availability layer, or developers can choose other options, depending on the specific needs of their layer too.
So flexibility and security from the ground up. What about this sequencer layer? It sounds kind of important.
It's critical.
Okay.
If the data availability layer is the library, then the sequencer layer is like the meticulous librarian who meticulously organizes and processes all the books, which in this case are transactions. They determine the order transactions are added to the blockchain.
So the sequencer layer is all about order and efficiency.
Precisely.
Wow.
And just like a library can have a single librarian or a whole team, the OP stack accommodates both single and multi-sequencers.
Interesting. So what are the trade-offs there?
So a single sequencer offers incredible speed and efficiency, but a multi-sequencer setup, while potentially a bit slower, provides enhanced security and resilience since there's no single point of failure.
Got it. The classic speed versus security trade-off that we see everywhere in the blockchain world. Okay, what comes next in the OP stack architecture?
The execution layer.
Okay.
This is where things get a bit technical, but essentially this layer is where the Ethereum virtual machine, or EVM, comes into play.
The EVM, the heart and soul of Ethereum. But we're talking about layer 2s here. How does that connection work?
That's where the brilliance of EVM equivalence comes in. The OP stack has been engineered to ensure that the environment on these layer 2s mirrors that of Ethereum itself.
Okay.
This is a game changer for developers.
Okay.
Imagine being able to take your existing Ethereum application and move it to this faster, cheaper layer 2 without a massive overhaul. That's the power of EVM equivalence.
That's huge. It's like being able to take your favorite app and instantly make it work somewhere new, just faster and smoother. Okay, we're on a roll. What's next?
Next up is the roll-up layer.
Okay.
Think about it this way. If you have a ton of packages to ship, it's way cheaper to bundle them together and send them in bulk, right?
Right.
That's the idea behind optimistic rollups.
Right.
They bundle transactions together, process them off of the main Ethereum blockchain, that busy highway we talked about, and then settle them back on Ethereum as one big transaction. This dramatically increases speed and cuts down on those pesky gas fees.
So efficiency is the name of the game with the roll-up layer.
Yeah.
But bundling things up, while great for speed, makes me wonder about security. What's preventing someone from slipping something bad into those bundles?
That's where our final layer steps in the proof and fault layer. This layer acts as a super vigilant security checkpoint. It's like having expert inspectors meticulously examining every single package in those bulk shipments.
Hmm.
If something seems off, even the slightest discrepancy, they can flag it and prevent the entire bundle from going through.
So it's about maintaining that balance of speed and security, even at the level of bundled transactions. It's like having the best of both worlds. This OP stack is starting to sound like a well-oiled machine.
Exactly. Each of these layers, the data availability layer, sequencer layer, execution layer, rollup layer, and the proof and fault layer work together seamlessly to make these layer 2 chains remarkably fast, significantly cheaper, and potentially even more secure than transacting directly on the main Ethereum network.
We've built this incredibly efficient, super fast system for processing transactions. But how does this all connect to the superchain? And what does it actually mean for someone like me or our listeners? Hold that thought because we'll be diving into the exciting world of the superchain and its real-world implications right after this. Okay, we've spent some time in the nuts and bolts of the OP stack, which is clearly a super highway for transactions. But it's the superchain that really captures the imagination.
Right.
It's like taking this incredible technology and using it to build a whole new world of interconnected possibilities.
Exactly. The superchain takes these individual layer 2s, each with its own strengths, and interconnects them into a network that's greater than the sum of its parts. Imagine instead of isolated ecosystems, we have this free flow of information assets and innovation across the entire blockchain space.
So no more blockchain islands, just one massive interconnected continent. I'm trying to wrap my head around the implications of that.
Yeah.
What makes the superchain fundamentally different from just having a bunch of layer twos doing their own thing?
The key difference, and it's a big one, is interoperability. Right now, if you want to use an application on one blockchain and then interact with another, it can feel like navigating a complex maze. You often need to use bridges, which can be slow, expensive, and even a bit risky. The superchain aims to do away with all of that by creating a standardized, secure way for these chains to communicate directly.
So rather than these clunky bridges, it's like building smooth, super fast highways between all these different blockchain ecosystems.
That's a great way to put it. And because all of these chains are built on the same foundation, the OP stack, this interoperability becomes much easier to achieve. It's like they all speak the same language, so communication is inherently smoother.
That shared language, that seamless communication, it sounds like a game changer for how we use and experience blockchain technology. But the superchain isn't just about interoperability, is it? What about scalability? Can it really handle a future where potentially millions, even billions of people are using blockchain-based applications?
That's precisely the goal. One of the biggest hurdles for traditional blockchains is that they can only process a limited number of transactions per second. The beauty of the superchain is that it leverages the power of horizontal scaling.
Okay, I've heard that term thrown around, but explain it to me like I'm just now hearing it for the first time.
Imagine you have a single checkout line at a busy store, and the line is getting incredibly long. You could try to make that one checkout line faster, but you'll eventually hit a ceiling. Horizontal scaling is like adding more checkout lines. So with the superchain, as more and more users and applications come online, you simply add more layer 2 chains to the network to handle the increased demand.
Ah, so instead of trying to cram everyone onto one super fast highway, you're building more highways as needed. It's a much more elegant solution for handling mass adoption. But if we're building this expansive, interconnected network of blockchains, security has to be the top priority. How does the superchain address that?
That's where the brilliance of Ethereum's existing security comes into play. One of the most ingenious aspects of the superchain is that it's deeply intertwined with Ethereum's security through a mechanism called restaking.
Restake it. I'll be honest, that's a new one for me. Break it down for me.
So Ethereum uses a proof of stake system, which means that validators stake or essentially lock up their ETH to help secure the network. Think of it like putting down a security deposit. With restaking, those same validators can use their staked ETH to secure the superchain as well. It's like having security guards who can use their expertise to protect an entire neighborhood without compromising the security of any individual building.
So by tapping into Ethereum's already robust security, the superchain gets to leverage this existing security infrastructure without having to start from scratch. That's incredibly clever. But I think what everyone wants to know is, what does this mean for the average user? What tangible benefits does the superchain actually deliver?
This is where things get really exciting. Imagine a world where you no longer have to worry about high gas fees eating into your crypto transactions. A world where you can seamlessly move between your favorite blockchain applications without a second thought, and a world where developers have the tools to unleash a whole new wave of innovation. That's the promise of the superchain.
Okay, I'm not going to lie, it all sounds a bit too good to be true. So let's dive into some concrete examples of what this future actually looks like. What are some of the specific benefits that the superchain could bring to users like me or like our listeners who are eager to explore this new world? All right, so we're talking about a future where the superchain could make blockchain technology more accessible and user-friendly than ever. But let's get specific. What are some real-world examples of how this could play out?
Sure, so let's start with the issue that makes everyone cringe.
Okay.
Gas fees.
Yeah.
Right now, it's like every time you want to make a transaction on Ethereum, you have to pay a toll, and sometimes that toll can be ridiculously high.
Yeah, absolutely.
The Superchain aims to solve this with a universal gas market.
Okay, less gas, more go. I'm already liking where this is going.
Yeah, so think of it this way. Instead of needing different currencies for every country you visit, imagine if you could use one single currency for everything. Yeah. That's the idea behind the universal gas market. You could have a single token, potentially something called the OMNI token, that you can use to pay for gas across the entire superchain.
So one token to rule them all.
Exactly.
That would be a game changer for simplicity and user experience.
Yeah.
No more scrambling to get the right tokens just to use a specific application. What else can we look forward to?
This is where the true power of interoperability comes in, is imagine playing an online game.
Okay.
Where you earn in-game items as NFTs on one blockchain with the Superchain. You could instantly use those items as collateral for a loan on a completely different DeFi platform on another blockchain, all thanks to the seamless communication layer of the Superchain.
Wow, that's a powerful example. It's like breaking down the walls between all these different blockchain applications and letting them interact in ways we haven't even thought of yet.
Exactly. This composability unlocks a whole new level of innovation. And for developers, the Superchain is like being handed the keys to a brand new high-tech workshop EVM equivalence. Makes it incredibly easy for them to take their existing Ethereum applications and plug them into this much larger, more scalable ecosystem.
So it's not just users who benefit, but the entire developer community has a chance to really push the boundaries of what's possible. We're talking lower fees,
Yeah.
faster transactions, seamless interactions, and a hotbed for innovation. What's the catch?
Well, the catch is that we're still in the early stages. Building something as ambitious as the Superchain takes time and a lot of collaboration, but the potential is there. We're witnessing the potential birth of a truly interconnected blockchain ecosystem, one that could redefine how we interact with the internet and with each other.
It's a bold vision, but from what we've unpacked today, the OP stack and the superchain seem like a solid foundation for this future. It really makes you think about the possibilities, doesn't it?
It does imagine a future where the internet is truly decentralized, where users have more control over their data, and where innovation can flourish without the limitations of traditional systems. That's the world the Superchain is being built to support.
It's an exciting time to be following the evolution of blockchain technology. A huge thank you to our expert for taking us on this deep dive into the OP stack and the superchain. It's clear that Optimism is building something truly revolutionary, and we can't wait to see how it all unfolds.
It was my pleasure. Always a fascinating topic to discuss.
And to all of you listening, thanks for joining us on this journey into the future of Web3. Until next time, keep exploring, keep asking questions, and keep diving deep into the world of blockchain.